This lesson is going to be on function composition today. What I want you to do is I want you to start thinking about what the word composition means. So I know a lot of you play baseball or you're involved in music, and generally when we think of the word composition, sometimes we think about things like composition baseball bats or a musical composition. Basically what that means is you're taking multiple items or multiple materials or multiple notes and you're placing them together to get this one finished product. So when we're talking about function composition, that's basically what we're doing. We're taking two, three functions and we're putting them together. We're taking a value and putting it into one function, getting an output and taking that value and putting it into another function to get this composition. Okay? So that's what we're going to be looking at today. So let's look at our exercise 1. Exercise 1 says, a circular garden with a radius of 15 feet is to be covered with topsoil at a cost of $1.25 per square foot of garden space. First thing we want to do is we want to determine the area of this garden to the nearest square foot. And then we want to determine how much it's going to cost to cover that garden with topsoil. This is a composition, okay? You're first finding the area and you're taking that information, you're placing it in to find the cost. So the output of one becomes the input to another, all right? So we know area of a circle is pi r squared, okay? So my area is pi times the radius, which we know is 15 squared. And when you put that right into your calculator, you get an area of 707 feet squared. Okay, so that's the area of my circular garden. So now that we have the area, we can talk about what the cost is going to be to cover that amount of space. If I know that my topsoil costs $1.25 per square foot and I have 707 square feet, what do I do with that? Well, we have 707 square feet at $1.25 a square foot. The cost of that becomes, when we do the multiplication, $883.75. That's an example of a composition. Okay, so what we're seeing is we're taking the input and it's becoming, or a value of x, we're putting it into a function. That output is going into the next function to get our final value, okay? So we have some notations that we're going to be using, and the notations here mean the same thing. So the way I say this is f of, right, here's my of, g of, the parentheses, 1. F of g of 1. This notation is the same, f of g of negative 2. Okay? They mean the same exact thing. They're done the same exact way. It's just different notation. Please keep in mind that this little circle here is not a multiplication sign. This does not mean multiplication. It means composition. So please be careful of that. So again, what we're doing here is we're doing a composition. You're taking a value, you're plugging it into the function to get an output. You're taking the output, you're plugging it into the next function as the input to get another output. The way we work with compositions is we always work right to left. Okay? I'm stating that my f of x, my function for f of x is x squared minus 5, and my function for g of x is 2x plus 3. We're going to find the values for each of the following. So, again, we're working right to left. So the first thing I'm going to do is I'm going to find g of 1. Okay? And we know how to evaluate a function at a specific value of x. We've done this for years and years now. It's just substitution. Okay? So we find the output of g of 1 to be 5. That's the output. The output now gets used as the input for the next function, which in my case, since I'm moving right to left, is f. So we're going to be doing f of 5. Again, substitution. We get f of 5 to be 20. So what is f of g of 1? F of g of 1 is your final output of 20. So again, you're moving right to left, and you're using substitution. So let's try another one, and then I'm going to have you, then we're going to have you doing on your own. We're actually going to skip down to D so that you can see what that notation looks like. Okay, so since we're moving right to left, I know I'm finding g of negative 2 to start. Okay, so 2 times negative 2 plus 3. G of negative 2 is negative 4 plus 3, which is negative 1. We're using that output for my next function, f of negative 1. We plug that in. Remember, when you square a negative, it becomes positive. Negative 1 squared is positive 1 minus 4 is negative 4. So f of g of negative 2 is negative 4. Okay, I'd like you to pause the video here, and I'd like you to do B and E on your own. When you are done, please unpause the video, and I will give you the solutions to see if you got them right. All right, so for B, you should have gotten g of f of 2 equals 1. And for E, you should have gotten g of f of 3 equals 11. If you did not get those, please make sure that you ask me in class tomorrow to go over them. Okay, so what if I want to use the same function twice? Let's say I wanted g of 0. Same concept, we're moving left to right. We're going to start by finding g of 0. Again, substitution. We get a value of 3. We're using that output, that 3, as my input for now g. So g of 3, we get a value of 9. Okay. Please pause the video here and try f. And when you're done, unpause. You will be required to show me the work for these 3 problems. So if I look into your notebook and I don't see any work written down and just the answers, there's going to be cause for concern. So please make sure that you're showing your work with all of the steps here. So pause the video and come back when you are done. Okay, so for f, you should have gotten a value of 11. Again, f of negative 1 should have been negative 4. F of negative 4 should have been 11. All right, let's continue on to the next page. And we're going to look at how we do these compositions using graphs. Okay, so we've got y equals f of x and y equals g of x. We're going to evaluate each of the following questions based on 2 graphs. Okay, so we've got our f of x and our g of x. So we're still doing composition, which means we're working right to left. So if I'm looking at A, I'm starting by finding the value of f of 2. And remember, this is f of x. So what that tells me is x is 2. I know f of x is y, right? So what this is asking me to do is, if x is 2, what's y? That's what I'm looking for, all right? So we're just doing that by looking at the graph. So if I want f of 2, I'm going to go to my f of x graph. I'm going to find the x value of 2, okay? And I want to know what is my y value. Oops, go away. My y value at x is 2 is 1, 2, 3. Okay, my y value is 3. So what's f of 2? It's 3. So now what am I looking for? I'm looking for g of 3. All right, f of 2 we said was equal to 3. So now I'm going to go to my g of x. And x here is 3. So 1, 2, 3. I need to know what is my y value. 1, 2, 3. My y value here is 3. So what is g of 3? It's 3. There's my whole composition. G of f of 2 is equal to 3. We're going to do this again. I know that this is new for you, so we are going to do it again together. Again, working right to left. We need g of negative 1. So now we're starting on the other function. X is negative 1. We need y. Negative 1, negative 2, negative 3, negative 4, negative 5. So g of negative 1 is negative 5. Again, you're finding the y value at negative 1. So now we need to find the y value at negative 5 in my f of x. So over to f of x. X is negative 5. So I'm going back, 1, 2, 3, 4, 5. What is my y value? It looks to be about negative 0.5. So my function, negative 0.5. Okay. So let's try it when we're doing a double composition using the same function. And then you're going to try the last three on your own. So we want g of 1, again, working right to left. G of 1 to start. So here's my x value. What is the y value at g of 1? 1, 2, 3. So now we need g of 3. So 1, 2, 3. What's my y value? 1, 2, 3. So g of 3 is equal to 3. So the whole function, g of 1, is 3. All right, I want you to take a few minutes. I want you to do D, E, and F, and then come back to see if you got those correct. Okay, for D, you should have gotten 3. For E, 2. And for F, 3. So again, if you don't show work, cause for concern. If you did not get them right, you will ask at the beginning of class tomorrow. Okay, so occasionally, instead of using numbers, we use the entire function in terms of its variables in order to do composition. So you do have to know how to do that as well. So I'm giving you the function f of x equals 3x minus 2 and g of x equals 5x plus 4. We want to determine the formulas in simplest y equals ax plus b form, which means we are going to do some simplifying out here. And we're going to do the composition of these functions. So again, the way I need you to think about this is we're moving right to left. The right function, the function on the right, in this case g of x, is going to go into f. Again, remember, it's f of x. What is the x being replaced with? It's being replaced with g of x. So here's g of x, 5x plus 4. It's going into the x of f of x. So we're taking this whole thing and it's going in for x. Again, it's just substitution. Okay? So the way this is going to be written, f of g of x, again, I'm taking all of g of x and placing it into the x for f of x. So instead of the x, it's going to be 5x plus 4. And then I have my minus 2. Okay, so I replaced the x in f of x right here with g of x. So now I do have to do some simplification, which means I'm going to have to distribute and then combine like terms so that it's in y equals mx plus b form. And that's your composed function. Let's do another together, and then I'll have you do the last one on your own to see if you can do that. Okay, so this time, instead of g going into f, it's the opposite way around. Again, we're moving right to left. F is going into the x of g. So here's my function, 3x plus 2. It's going into the x in g of x. So g of f of x. I'm starting with this function, 5. Now I'm putting in my f of x, 3x minus 2. Don't lose the rest of g of x, plus 4. We're going to distribute. And we're going to combine like terms. Notice I'm bringing down my f of g of x and my g of f of x each step. You should be doing that as well. Please don't leave that out. All right, so exercise 5, I want you to try that composition again. Remember, you're working right to left, so g is going into f. You are going to have to do a little bit of algebra here, so please take the time to do it. Pause your video and come back to see if you've gotten it right. Okay, so with this one, again, G is going into F. So when you did this, you should have F of G of X. Here's your G going into the X, which means you are going to have to square this function. Okay? Which means you're going to have to multiply the two binomials together. Should have gotten x squared minus 10x plus 25. Choice 4. All right, make sure that you come prepared to class with any questions that you may have had from this video. Remember, you are required to do the questions that are in Edpuzzle along the way throughout the video. So if you did not do them or do them at the best of your ability, make sure that that doesn't happen again. And I will see you tomorrow. Thanks, guys.